Hello, so I finally have a prototype of the pedal steel guitar. So this is basically a test panel with just one string. So what I have here is I have a tuning peg. These are just some 3D printed blocks, the black plastic blocks here. I have a tuning peg on the first one, and then I bought these. These are for a guitar bridge. I don't remember what exactly they're called, but they're basically a little metal piece with a wheel on them that the string can roll over. And there's two threaded holes. I believe it's an M2. And so I just, mounted those to these plastic blocks and mounted them to the board. So I have the string going over those rollers. And so at a high level, I have the tuning peg, I have one roller, so this would be like the nut of the guitar. And then I have the span length of the guitar, and then I have a second roller. So this would be the bridge essentially. And then I have here a span length to another roller. This span length is where I'm actually bending the string. So I'm pulling down here perpendicularly with the servo motor. The servo has a little wheel on it, which I 3D printed. And after that bending area, then we just go to another tuning peg. No particular reason, it's just the easiest way easiest thing I had to be able to secure it at the other end. So that's what we have. And you can notice that I have it set up so that there's like a little curvature to the string. The reason is to ensure that there's always downward force on each roller. So if you can imagine, if all the rollers were exactly the same, across the same line, then you could have some buzzing because unless they're perfectly, well, even if they were perfectly straight, aligned with each other, you would not have some downward pressure on each roller. So I kind of, offset each next point of contact lower than the previous one to ensure that there's always downward force on each roller. So basically what I have set up here electronically is I have an Arduino. I'm driving the one servo motor through this servo driver, and I have a little breadboard here with two potentiometers. So I'm using the potentiometers as inputs to the Arduino. So I'm reading them on this analog input pin. And I have a two position, so I guess this would be I think there's a double pole, double throw switch. And I'm using one pole, but I'm using both throws. So basically, in one position, I'm piping the value from one potentiometer, and in the other position, I'm piping the value from the other potentiometer. So what I did as a test is I just tuned the first potentiometer to have, the right amount of tension on this puller to produce a guitar high E string sound. This is a high E string for a guitar. So I have that, and then if you flip the switch, you'll see that, flip it here, and you see that the puller pulls down, and now we have F. Might be a little out of tune, but that's the idea. And then if I flip back, goes down to E, back up to F. So that's just a little proof of concept. And I'm already noticing some issues. The servo's a little shaky. You could probably hear it when it's holding the tension. I have to figure out why exactly that's happening. That might just always be the case when it's under tension. So I might have to put a counterbalance spring on the back to basically keep the tension off of it unless it's actually bending a string. I could also change the mechanism so that there's less force or less torque on the servo at all. And let's see, a couple other things I noticed. I broke a string because of the way I had it secured at this end, so I had to change that a little bit. So previously I just had this little ring here right through the hole, and that kind of holding it there, but it broke at that point, so I changed it to wrap around just like you would at the top end of the guitar. Let's see, what else did I notice? The servo's kind of slow. That's another thing. So if you're actually playing this thing as a pedal steel, then you can see how long it takes to change positions. So if you're doing fast playing, that's not really practical. So I'm gonna have to figure out a way to make the transition faster. I don't know if that means that a servo is not the right actuator, or if it means that I need to change the mechanism to be faster, which also means I'm gonna have to have more power. It might actually correct itself if I provide a higher power source. Right now I only have 300 milliamps coming in through this external power source here. I have to read the specs of this motor and see what it really needs to, pull a particular amount of torque. So there could be some improvement just in providing the right power level. But yeah, basically that's it. And so from here, just gonna keep, tweaking the design, learn some things from this prototype, and then, ultimately expand the design to 10 strings and, make it all compact. And the servo is also very loud. So obviously that you don't want to hear that when you're playing a guitar. So I have to design that into some kind of acoustic insulating box or something, or find a quieter actuator. So that's another thing to look at. So anyway, yeah, that's where I'm at, and hope you find it interesting. Thanks.